some specific heat capacities. Better you learn these values so you don't have to bother about the final answer if you learn these values. So for water, the specific heat capacity is 4,200. It's like 4,186, but rounded off, 4,200 joule per kilogram degree centigrade or Kelvin, same thing. For aluminium, it is about 890, so you can take as 900 approximately joule per kilogram degree centigrade. Then for copper, and iron is there 448. Joules per kilogram degree centigrade, and the last one is copper, which is 387 joule per kilogram degree centigrade. So what is the meaning of these values? It means that if I have water, if I have a container, because water is a liquid, so you should have a container in which water it is filled with water. So if you have a container which is filled with water and the mass of the water inside the container is 1 kg. So you have 1 kilogram of water. You supply energy. Say the initial temperature of this water is 18 degrees centigrade. So you will supply energy so that the water temperature rises from 18 degrees centigrade to 19 degrees. So how much energy we need to increase this temperature of water? We need 4,200 joules. So basically what's the meaning of this? It means if we have 1 kilogram object and we want to change the temperature of this object by 1 degree centigrade, so how much energy is required? We required 4,200 joules of energy. That's a simple meaning of specific heat capacity. Same thing, if you have a block of aluminium, so if you have a block of aluminium and the mass of this piece is 1 kg, and the temperature of aluminium, example, it is 30, and you want to change from 30 to 31. So if you want to change the temperature of 1 kilogram piece of aluminium by 1 degree centigrade, so how much energy is required? You required 900 joules. You have to supply 900 joules so that the temperature will change by 1 degree centigrade. And same way it's valid for iron as well. So if you have a piece of iron, and the mass of this iron is 1 kilogram, and initially it is at example 40 degrees centigrade, and you change the temperature from 40 to 41. So how much energy is required for this piece of iron? Iron symbol I'm writing Fe. So how much energy is required to change its temperature by 1 degree? So you required 400 and 48 so that it changes temperature by 1 degree. And this is valid both cases. If we want to decrease the temperature, we will remove the energy. If we want to increase the temperature, we will supply the energy. But same amount of energy supplied or removed so that we can change the temperature by 1 degree centigrade. Is it clear the concept of specific heat capacity and thermal capacity? Take the screenshot. Now I'll give some questions related to heat capacity and thermal capacity.
Sir, what's the relationship like between mass and the energy supplied, like the specific heat capacity?
Inversely proportional, actually. Because if you have more matter, you have this formula, like specific heat capacity is energy divided by mass into temperature change. So if all the factors are same, the one which is having smaller mass will have higher specific heat capacity.
Yeah, okay.
The difference between the thermal capacity and specific heat capacity So what is the main difference between the two quantities? First thing is from definition, like thermal capacity, it is energy supplied to change the temperature by 1 degree. That's the first thing. Like how much energy required to change temperature by 1 degree centigrade or 1 Kelvin. But what is specific heat capacity? Specific heat capacity is energy required to change temperature of 1 kg by 1 degree centigrade. Means the mass is specified. It's we are always talking for 1 kilogram. Like how much energy is required for 1 kilogram so that its temperature change by 1 degree centigrade. So if I take the formula here for thermal capacity, is equals to energy divided by temperature change. For specific heat capacity, is equals to energy divided by mass multiplied by temperature change. So if I take the same examples, here is an object. I have 5 kilogram object. And I supplied 10,000 joules so that its temperature changes from 20 degrees centigrade to 22 degrees centigrade. So thermal capacity means how much energy supplied so that the overall temperature of the material increases by 1 degree. That's called thermal capacity. So we have 5 kilogram object, we change the temperature from 20 to 22. We supply example 10,000 joules. I wrote 1,000 initially, but we example supply 10,000 joules, so that temperature changes from 20 degrees to 22. So what is the thermal capacity? How thermal capacity means how much energy is required to change the temperature by 1 degree for whole object. So for whole object, how much energy is required? So that's 10,000 is the total energy absorbed divided by temperature change, which is 2 degrees. So when I solve this, it will be 5,000 joules per degree centigrade. What is the meaning of 5,000 joule per degree centigrade? It means I required 5,000 joules so that I can change the temperature of this object by 1 degree. That is thermal capacity. But if I say what is specific heat capacity, specific heat capacity means how much energy is required to change the temperature of 1 kilogram object by 1 degree. Like this is for 5 kilogram object, but we need for each kilogram or 1 kilogram. So what I will do, I will find the specific heat capacity. So that's 10,000, the energy supplied, divided by mass. The mass is 5 divided by temperature change, which is 2. So when I solve, this is 10,000 divided by 10. So what I will get? I will get 1,000 joules per kilogram per degree centigrade. So what it shows that for every kilogram, for each kilogram, I need 1,000 joules so that the temperature of each kilogram will change by 1 degree centigrade. So thermal capacity is for whole object. Specific heat capacity for 1 kilogram object, how much energy is required. Is it clear the difference between the two quantities, thermal capacity, or you can also say heat capacity? Any doubt in this point?
Sir,
Yeah.
so for every kilogram in an object, for
Yeah.
example, in this 5 kilogram, if I increase that like to 10, that means that the amount of energy for every kilogram, like the specific heat capacity required to change to 1 degree Celsius, will decrease.
No, but the thing is, what happened, the temperature, when you're supplying the energy, the temperature change will also increase. Like 10,000 joules is causing, example, a temperature change from 20 degree to 22. But when you supply a higher energy, then the temperature change will also, the mass is changed. Example, you double the mass. If the mass is changed, so you need a greater amount of energy to produce the same change in temperature. Specific heat capacity will remain constant. The idea is that the specific heat capacity does not change for the same material. Like example, if I have 2 kilogram piece of iron, I have 5 kilogram piece of iron, I have 10 kg piece of iron. What will be the similarity? They all have same thermal specific heat capacities. Specific heat capacity will be same. For each kilogram, they require the same amount of energy. But the thermal capacity will be different because a large piece of iron can store greater amount of energy as compared to smaller piece of iron. Is it clear?
So the
Yes.
specific heat capacity is basically like independent of the mass of the object.
Yeah, specific heat capacity independent of mass of an object. When you're comparing, when I told you the relation between specific heat capacity and mass, they are inversely proportional. That is a comparison with other substance. I will come to
Yeah,
that point.
yeah.
I was compare that my explanation was according to when you're comparing the two substances. My answer was not according to when you have one substance, it is independent of what is the mass of a substance. All will have the same specific heat capacity.
Yeah, yeah.
Sir,
Got it.
Yes.
sir, so thermal capacity tells us how much energy can be stored, right?
Right. And specific heat capacity is for 1 kilogram, how much energy required or stored for 1 kilogram so that the temperature change by 1 degree centigrade.
Okay.
Is it clear?
Yes.
Sir, I'm sorry for interrupting again.
Yeah.
Sorry. So so any energy, for example, for water, we have 4,200 joules per degree Celsius in kilograms. So
Yeah.
any energy like below that, it will not cause a change. It will be stored. But any once
No,
it
no,
reached that,
no, no, not is. It's like it will, for 1 degree change in temperature, if you have a container which is filled with water, if I want, like example, I'm supplying, what is the meaning of this 4,200? It means if I need a 1 degree change in temperature, I should supply 4,000 joules for 1 kilogram. But for example, if I'm not able to supply 4,000, I'm able to supply 2,100. So how much temperature change this will cause? This will, because if 4,200 cause a 1 degree change in temperature, 2,100 will cause a half degree change in temperature. It will cause a change in temperature, but not 1 degree change in temperature. 1 degree change in temperature is only caused when we supply 4,200 joules for 1 kilogram of water. Is it clear?
yes, sir.
Take the screenshot, then I'll give more example. Specific energy can be thermal capacity by dividing. It is opposite. Specific energy is thermal capacity divided by mass. That's also right. Thermal capacity divided by mass, you will get specific heat capacity. You can see here only difference is division by mass. So specific heat capacity is equals to thermal capacity divided by mass. That's a formula which relate both of them together. So the basic idea, thermal capacity is energy required to change the temperature of a given substance like any mass by 1 degree. But specific is for, you have whole object, but you're not talking about whole object. For each kilogram, how much energy is required so that its temperature change by 1 degree for each kilogram. That energy is called specific heat capacity. So specific heat capacities for material is constant, but thermal capacity can be different. It depends on amount or the size of the sample. So example, uh, 3 kilogram or 4 kilogram object at 10 degrees centigrade absorb take 4,000 joules. So its temperature rise to 13 degrees centigrade. Question is, find thermal capacity or heat capacity and specific heat capacity. So 4 kilogram object at 10 degrees centigrade takes 4,000 joules so that its temperature rises to 13 degrees. The question is find heat capacity and specific heat capacity. So if we need heat capacity or thermal capacity, heat capacity means how much energy is required so that temperature of whole object changes by 1 degree. And the formula is energy divided by temperature change. So the energy which you supply 4,000 joules divided by temperature change. What is the temperature change? That's originally it was 10, now it is 13. So what is the temperature change? That's equal to 3. So 4,000 divided by 3. What's the answer? 1,333. So what it shows 1,333 joules per degree centigrade. Means for every 1 degree, for changing or to cause a change in 1 degree centigrade of this object, the temperature change of 1 degree centigrade, we need 1,333 joules. But what is the specific heat capacity? So specific heat capacity is energy divided by mass into temperature change. Energy we supply 4,000. The mass of object is 4 and the temperature change is 3. What's the answer? 1,000 divided by 3. So I think 600. It will be 633. 333. Sorry, yeah. 333 joules per kilogram degree centigrade. So what does it mean? It means for every 1 kilogram of the object, like you have 4 kilogram object, but for each you have 4 kilogram, but for 1 kilogram of this, it required 333 joules so that its temperature change by 1 degree centigrade. Is it clear? The concept of specific heat capacity and heat capacity or thermal capacity. Check the screenshot. I will give another example.
Sir,
Yes.
sir, both thermal capacity and specific heat capacity tells us about the energy needed to raise or decrease the temperature, right?
Right.
Then
But,
what does mass have to do with this? Like,
yeah, but the
why
thing is, yeah,
different formula for mass?
heat capacity is for the total energy required for the given object. But specific is when we say how much energy is required for 1 kilogram. Heat capacity, you can have any mass. You can have 1 kilogram, 2 kilogram, 100 kilogram, 1,000 kilogram. Any mass is there. How much energy is required to increase or decrease the temperature by 1? We call heat capacity. But if we specifically work out how much energy is required for 1 kilogram of that object, we have like a sample can be 100 kilogram, but we are not talking about whole sample. We are just finding for each kilogram object how much energy is required. We call that as specific heat capacity. So that's the main difference, that heat capacity explain the total energy required for the object. Specific heat capacity explain for 1 kilogram object is there, how much energy is required to change the temperature by 1 degree centigrade. That's the main difference between them.
So, like, when I want to find out the energy needed to raise a temperature or decrease a temperature, specific heat capacity will be more accurate, right?
Yeah, specific heat capacity will be more accurate, because if I know how much is there how much energy is required for 1 kilogram. So I can simply multiply it by mass. So I will know what is the total energy required.
Okay, sir. Thank you very much.
So normally when we supply heat energy in the lab, we use electrical heater. And the formula to find energy supplied by the heater you have to learn this formula, that energy supplied by the heater. Normally in the lab we use electrical heaters, not burner. In chemistry lab we use burners because the energy calculation is not done. Like we don't have to bother about how much energy we supply for most of the reactions. But in physics we have to be specific because the value of the energy should be known. That's why we use electrical heater. So when you are using electrical heater, the formula to calculate the energy supplied by the heater, there are two formulas. One is the power of the heater multiplied by time for which heater is switched on. That's one thing. So example, if I say you have electrical heater, so this is an electrical heater. You connect with a battery supply. So when you switch on this heater, it will release the energy, heat energy. So how much energy is released by the heater? How I can find? So simple formula, energy supplied by the heater is power of the heater multiplied by time for it heater switched on. So if I say a 30-watt heater, what is the unit of power used for 2 minutes? Find energy supplied by heater. So if a 30-watt heater is used for 2 minutes, I need an energy supplied by the heater. So what is the formula to calculate energy supplied by the heater? Energy supplied by the heater is power multiplied by time. What is the power of the heater? 30. What is the time I should use here? It's operated for 2 minutes. So what is the time I use here? So time, we always use the SI unit of a time. Because it is in minutes, minutes is not an SI unit. So we always use time should always be in seconds. So you multiply by 60, so that will be 120 seconds. So when you multiply 3 multiplied by 12, that's equal to 36. And then two zeros are there. So 3600 joules is the energy which is supplied by this heater. So when we supply heat energy, we normally use electrical heaters, and electrical heaters, the energy the formula which we use is equal to power multiplied by time. So power of the heater multiplied by time, we just multiply them. The thing which you have to keep in mind, that time should always be in seconds. If time is in minutes, it's in hours, you have to convert into seconds. Is it clear? The formula about, so you have to learn this formula. Actually it is the same formula, as you know, power is energy divided by time, or work done divided by time. So if we need energy, energy is power multiplied by time. take the screenshot of this. Some questions, voltage and current of the circuit are given. So what you will do, if voltage and current of the circuit are given, then what you will do, you will find the power, because electrical power is equals to voltage multiplied by current. So first in that case, you have to find current. First in that case, you have to find power. And after finding a power, you will solve the question to get the energy. I will give this example. If I say an electrical heater is connected to 20-volt supply, allow 5 ampere, ampere is a unit of current, to pass, calculate energy supplied by the heater if it is used for 3 minutes. So an electrical heater is connected to 20-volt supply, which allow 5 ampere to pass. So this is actually a voltage. 20 volts, that's a voltage, and 5 ampere is a current. Ampere is a unit of current. You need energy supplied. So to get the energy supplied, as we discussed, the energy supplied by the heater is equals to power of the heater multiplied by time for which the heater is switched on. So energy is power multiplied by time, but we don't know the power. So first we have to find the power. So if we find the power, as we know, power is voltage multiplied by current. Current is denoted by I. So voltage is 20 multiplied by current, which is 5. So 20 multiplied by 5. 5 multiplied by 2 is 10, and then 0 is there. So it will be 100 watt. So we have the power, which is 100, multiplied by how much time we switch on this heater for 3 minutes. 3 minutes we have to convert. We'll multiply by 60, so it will be 180 seconds. So this will be equal to 180. So when we multiply them, so this will be 1000, sorry, 18,000 joules, or 18 kilojoule, you can also say. Is it clear? So it depends on the question that whether they give you power directly, or sometimes they give you voltage and current, and you will have to work out the power. So if there's example, calculate energy supplied by heater connected to 240-volt supply, allow 2 amperes for 5 minutes. Yeah, solve this question. What's the answer? Calculate energy supplied by the heater connected to 240-volt supply, allow 240-volt supply allow 2 ampere for 5 minutes. So 144,000. So because you need energy, energy is power, power multiplied by time, and power, it's the product of, I will do both in the same part. Yeah, so 144,000. So it will be 240 multiplied by 2 multiplied by time is 5, but we have to convert into seconds, so we multiply by 60. So when we multiply all the factors, what we will get? We will get 144,000 joules. This is the energy which we supply. This is example, the first part. The second part, calculate thermal capacity if heater supply same energy to 5 kg object, produce 2-degree change in temperature. Yeah, calculate the thermal capacity if heater supply the same energy to 5 kilogram and which produce 2-degree change in temperature. So what will be the answer? Because if you need thermal capacity is denoted by capital C, which is the energy which you supply, 144,000 divided by 2, that's equal to 72,000. So 72,000 joules per degree centigrade. And if part C, calculate specific heat capacity. So specific heat capacity is energy divided by mass, or thermal capacity divided by mass. So mass of object is 5 kilogram. You have to divide by 5. So 72,000 divided by 5. Because specific heat capacity, I will solve here. So 72,000 divided by 5. What's the answer for this? So 14,400 joules per kilogram degree centigrade. Is it clear?